Okay, so let's start. First time I'm doing this thing, the crash course online. Okay, because of this corona breakdown, we can't do offline classes. So let's give it a try. I don't know how it will be delivered. Just giving it a first try. Okay, taking the crash course for NEET means you can also take it as JEE mains, because we don't know for indefinite period of time. For indefinite period of time, the whole thing has been delayed. So we can assume JEE mains is also one of the focus. So before starting, what we will be planning to do is that I will create a WhatsApp group of the crash course. Okay, in there I will be selecting approximately, you say, 100 MCQs per chapter. 100 MCQs per chapter. I will be targeting to select this 100 MCQs and I will be solving few of them, and rest I will be clearing the doubts. Okay, so this is the way, and this 100 MCQs will be given as PDF to the corresponding mail ID and in the WhatsApp group. Okay, in the PDF format. Okay, so let's start. So before and all the key points, we will have a list of the key points, because in this we can't go to the deep into the theory. We need to have the just brush up of all the things and then direct application. Okay, so let's give it a small try. If it is successful, then we'll go for the bigger version of this class. First of all, which is the one of the most important chapter, which we think it's easy but it's tough to do. I feel it's mechanics. So we will be doing one chapter of class 11 and one chapter of class 12 parallelly, so that we can complete the whole scenario in this good amount of time. So first, if I start off with mechanics, there we have errors and dimensions and units and measurement. I will be doing that in the later half. Okay, let's start off with my favorite. It is motion in 1D and 2D. Now see, motion in 1D and 2D, I will try to club it up. Okay, and the vector motion I will do it separate. Okay, so what is the main thing we require in motion in 1D and 2D? First, we will use something. Motion in 1D is two things. It is uniform accelerated motion. Other is non-uniform accelerated motion. Two important things. Now, if I am talking about 1D motion, first it is along a straight line. 1D motion, it is, we use something, general case study. See, xt is something called position. See, this is all applicable in motion in 2D also. So keep in mind, once I am doing the motion in 1D, it is same applicable in motion in 2D. Okay, xt, position time curve. Vt, velocity time. At, acceleration time. It is along one axis. Now you have to find the relation between this thing. If I want Vt along, say it is along any axis, it can be either x axis, it can be along either y axis, it can be along either z axis. Vxt can be given as dxt dt. See, this is V instantaneous. Acceleration t along x-axis given as dv x dt. Now, sir, what is the major thing? What is the acceleration along x written in this way? Vx dvx dx. Now, I think you know this concept. Now, this is the most important thing in 1D. Okay. This thing, if I write something like this, Vyt dyt dt, it goes with 2D. See, simple scenario. Now the reverse one. Reverse is important. Okay, reverse one is very important because this type of sums I have seen giving many applications in NEET and JEE mains is Over here it is xt. Please keep in mind it is xt dxt from x1 to x2 is equals to integration vx dt from t1 to t2. Now dxt means it signifies x at time t2 minus x at time t1. Now this is the difference of the two positions. Now this is the checkpoint where students get confused. This is not displacement. This is the difference of the two position. This difference of the two position is termed as displacement. I have seen in my career key students do confuse. They think both as a displacement. No, both are not displacement. The difference between them is displacement. X is only the position at that time instant. And here you write it as t1, t2, vx dt. Simple. Similarly, from this concept we can write v at t2 minus v at t1. The difference in the velocity is given as t1 to t2 ax dt. That means we are only talking about the change of velocity along which direction? The change of velocity along the x direction. The change of velocity along the x direction. See, this is, I have started with the calculus based, then I will go with the normal thing and then I will reciprocate this thing in the sums. Okay? So I hope so. From this to this is clear. The difference between them is displacement. Okay? And the difference between the two velocities is the change in velocity. So here goes the concept of motion in 1D. So do one thing. Once I have done this complete board, give a pause, note it down, then again play it. Okay, so what we have got finally, x at t2 minus x at t1 is equals to integration vx dt. I am not writing for the same scenario with the y-axis because it's same. Okay, now v at t2 minus v at t1 is equals to t1 to t2 a dt. It can be x-axis, it can be y-axis. If acceleration is constant. Now this is a special scenario. If acceleration is constant along any axis, say a naught, then this thing is reduced to something like this: x at t2 minus x at t1. Check this thing out. First this get reduced. V at t2 minus v at t1. Acceleration constant, a t2 minus t1. Check it out. Acceleration out of the box, it's a naught, then dt, t2 minus t1. You know this thing. Now for our reference, let t1 tends to 0, t2 tends to t. And for this case, v0 is named as u and v at any instant t is named as normal v. It becomes v minus u is equals to a naught into t. Here goes the beautiful thing. And we have, if the acceleration is constant, see this only happens if the acceleration is constant. And similarly, v is equals to u plus at, then it will be u plus at dt from 0 to t. Then it will be x0, it will be xt. Check this thing. So xt minus x0 is equals to ut plus half at square. Keep in mind, this is very important because what I am going to show right now will be on this basis. This xt is the position at time t. And this is position at time t equals to 0. T equal to 0 means the time where the observer starts noting the time. And this difference is written as displacement. Then we have another thing, V average is equals to U plus V by 2. Now, please keep in mind this concept of V average, this thing can only be applied if acceleration is constant. If acceleration is not constant, you cannot apply this thing. Next, what we have? We have displacement can also be given in this way, u plus v by 2 into t. These are the important things which will be required while solving the sums. Twice as. We know this thing. Now, we have another important thing, displacement. I have found many students going wrong in this concept. Displacement in the nth second. Keep in mind what I am trying to say. Displacement in the nth second. Now here the difference has to be of 1 second. Please note it down carefully. The displacement has to be, the difference of the displacement has to be of the 1 second. If the displacement is the difference of 1 second, then only you can apply this. Means if I say S10, S10 means, it means displacement after t equals to 9 to t equals to 10. This is, if anyone says ki find the displacement, say find the displacement. Achha, first write the formula. In this case, when the displacement is of the difference 1 second, then Snth is given in this way, u plus a by 2 to n minus 1. Now this n can be any number, but the difference has to be of how much second? 1 second. The displacement has to be of 1 second. Now check this thing out. I am giving you a small hint. A body starts from rest. A body starts from rest. Find the displacement in 5th half second. Find the displacement in the 5th half second. Okay. While I will be solving this sum, you give a pause, try to solve it on your own, then check my solution. Okay. I hope this whole segment is clear. In this whole segment, you get a cheat sheet of how to apply. Okay. So, now, so what we have find ki displacement in 5th half second. That means what? 5th half second. Acceleration say given over there is something say 2 meter per second square. Say I have not stated ki acceleration is 2 meter per second square. Means if I divide half, suppose this was t equal to 0. So this was t equals to half second, this was t equals to 1 second, this was t equals to 1.5, this is t equals to 2, this is t equals to 2.5. That means you are only required to find the displacement between these two. Is the difference of the interval is 1 second? No. The difference of the interval is not 1 second. I have seen many students applying something like this. Okay, u is 0, initially it starts from rest, half a is 2, then 2 into 2.5 minus 1, this goes mistake. Because the difference is not 1 second. So difference has to be of the 1 second, or else you can't apply that formula. So over here, so what we do, so simple. Logically S 2.5, sir, how to find S 2.5? Initially starting from rest, I have given it starts from rest. Okay, if it is not mentioned it starts from rest, you cannot use starts from rest. Then it's ut plus half at square. And what is S2? Same, that is ut2, ut plus half at T1 square. Subtract this thing, S 2.5 minus S2. You get the answer. You get the answer. Over here it is 2.5, over here it will 2, you get the answer. So you can't apply this over here. Similarly, we have another interesting topic. Yeah, let me do with few sums. Before doing the few sums, I will delve some more into theory. The concept of t equal to 0. Now this is very interesting. We see it does not mean the body is at rest. It is a reference of solving sums. It's a reference of solving sums. It can be chosen according to you. It can be chosen according to you. Now I will show it. Okay. It does not mean that the body is at rest. It does not mean that the body is at rest. The body can have any velocity. So, sir, here we go with the next beautiful sum. Okay. A body covers 100 meter in 10 seconds. 300 meter in 200 meter in next 10 seconds. How much meter in next 10 seconds? See, this is beautiful. One thing, it is assuming, it's given in the question, assuming uniform acceleration. Assuming uniform acceleration. Now, I have seen many students using shortcuts and doing. Okay, we will see how to do normally, and if possible, whether we can use any sort of shortcuts or not on solving the sums. So I give a pause, you give it, you solve it, then check the solution. Now, what I say, 100 meter in 10 seconds. Now, students think it's 100 meter in first 10 seconds. Have I ever told you that 100 meter has to be in the first 10 seconds? No, I have not told you. So, why you are thinking 200 meter in next 10 seconds? Yeah, this is, so if I don't know, you take this thing as your reference. Suppose this is 100 meter, you don't know, let u be the velocity, you take this as your reference, t equal to 0, this becomes t equals to 10, this becomes t equals to 20. Next 10 seconds, it has moved 200 and you require how much it will move in the next. So it is not something geometry, okay? If it is moving with uniform acceleration A, so this is our assumption of t equal to 0. See the application of t equal to 0. I have assumed let this be the t equal to 0 and the body is having an initial velocity u. So I write 100 is equals to u into 10 plus half a into 10 square, that is 100. Now taking this as the reference, for the first 20 seconds it will be 300. Check. U into 20 plus half a into 400. Now sir, simply eliminate u and a, either u or a. So how to do, sir? Multiply by 2 and subtract. Multiply by 2, if you subtract, it will be minus 100. This goes cancel off. This is 200, this is 400. Okay, so it will be 100 minus 200. It is minus 100 a. A will be equals to 1. If a equals to 1, so what is the value? So 100 is equals to 10u plus 50a. If a value is 1, u is equals to 5 meter per second. See what we have got. We have got u, we have got a. Now we require this thing. This is the difference. So what we find S30 from here till here. So how it will be 5 into 30 plus half 1 into 30 square is 900. 150 plus 450 is equals to 600. Total is 600. Total is 600 minus the 100. It equals to 300. Now don't say, sir, it is increasing arithmetically. No, please don't say. These are all the. This is only for this type of sums. We have to solve like this thing. Okay? Another one I will show you with another example. Here we have. This is one of the popular sums. You must be having this sums in every textbook, every NEET question, many JEE Mains question. Okay. A bullet loses 1 by nth of its velocity while passing through a plan. A bullet loses 1 nth of its velocity while passing through a plan. Find how many such planks must be placed side by side so as to stop the bullet. Now this is one of my favorite sums. Okay, I give in every examination, good examination, I give this type of sums. Okay. So this is a beautiful concept. I will use this t equal to 0 concept to solve this one. There is no shortcuts. Okay, if you try to memorize a formula, people try to memorize a formula of no use. In the examination hall, if there is by any chance you will forget the formula, you are lost over here. It will take hardly 30 seconds to solve a sum. Now, assuming two things we will assume. Planks placed side by side. Planks are placed side by side and uniform thickness. And each plank is offering the same resistive force. Means this is all the thing which will be given. Each plank is offering the same resistive force. Okay. So how we go with this thing? Let's draw a plank. Suppose x is the thickness of one plank. This is nx. Let's say n number of planks required. Nx. So if x is the thickness of one plank, so total planks, let us say x. If the bullet starts from here, say u. If the bullet starts from here, u, it loses 1/nth of its velocity. So let's say this is u dash, and in this case the velocity drops to 0. The velocity drops to 0, and we have assumed each plank is offering the same resistive force A in this thing. Same resistive force A. So how you write? If you remember this thing, we have given u dash square minus u square is equal to twice ax. Yeah? V square minus u square. And another equation you can write from here to here. 0 minus u square is equal to twice a nx. I think you have got this thing clear. Simple, sir. You divide these two equations. U dash square minus u square is equals to by minus u square is equals to 1 by n. Reverse it and take the negative sign out of the equation. Means it will be u square by u square minus u dash square. Now, what is u dash? U dash is nothing. It loses 1/nth of its velocity. Means u minus u by n. Check this thing out. U minus u by n. It comes out to u 1 minus 1 by n. U dash by u is equals to 1 minus 1 by n. So over here I do something like this, 1 by 1 minus u dash by u full whole square. I hope this you have got this thing clear. So it becomes how much? 1 minus 1 by 1 minus 1 by n whole square. If you solve it, you get the required answer. So what is the answer? Sir, can you just brief it out? 1 minus 2n. This is the total I think 1 by nth, and this is let's total number of planks is m. Name it as m number of planks. So you will not get confused. M. So this is a beautiful way of approaching the t equal to 0. See, I have taken this as my t equal to 0. So now a similar type of this thing, then we move on to the next type. Now, what's the next type? Key front end of the train crosses a lamp post with speed u, and the last end crosses the lamp post with a speed v. Find the speed when 3/4 of the train has crossed the lamp post. Now this is a very confusing one. So first case, this is a lamp post, the train is about to cross. Next case, the train has crossed, and over here we require the 3/4 has crossed. Now in this case, say this becomes your t equal to 0. Okay, in this case the train was having v, u, v, the speed of the train. Let's say the length is x. Okay, in this case how much it has crossed? 3/4 x has crossed. Now two things, one with this, another with this. Okay, you have to find v, u dash. So if I compare these two situations where total displacement is x, acceleration is this thing, final velocity is v, initial velocity is u. So v square minus u square is equal to 2ax, and this with this, u dash square minus u square is equal to twice a 3/4 of x. Check this thing out. This is a damn easy thing. Now what we need to have? We need to find u dash in terms of v and u. You divide all this scenario. What I got? V square minus u square, u dash minus u square is equals to 4 by 3. 3v square minus 3u square, 4u dash square minus 4u square. 3v square plus u square by 4 root over is u dash. Here we move on to the next one. So another beautiful sum. So what? Let's write the sum. You do it on your own. This I have shown you. Okay. Let's do something theoretical. Then I will proceed with the sum. Okay, ना चलो काम करते हैं. पहले सम दे ही देते. A body अच्छा, give this equation now. You don't know. xt is given as 3t square minus 12t plus 9. Like this. Now first important thing, key, find the Many questions do come with this expression. Many questions. You check out the NEET papers and the JEE Mains papers. Find the displacement at t equals to 3. Now this is a wrong term. You can't say find the displacement at t equals to 3. You can't say find the displacement between t equal to 0 to t equals to 3. This is the correct. In many question papers I have seen find the displacement at t equals to 3. It's a wrong thing. Okay, because over here this is a constant. The constant signifies the body is not at the origin. The body is not at the origin. Okay. So how to solve this thing? I will show you. Now, so first, this is position time curve, not displacement time. So how to check? X0, it comes 9. If it comes 9, that means it is already having a position. And displacement at t equal to 0 is always 0. Displacement at t equal to 0 has to be 0 always. So this is not a displacement time equation. This is a position time equation. So what is the thing? From t equal to 0 to t equal to 3. Find the position at t equals to 3. 3 square minus 12 into 3 plus 9. So this comes 27 minus 36 plus 9. So that is 0. Now, people do confuse. They will write 0. No, the answer is not 0. So displacement is x3 minus x0. I have told you it becomes 0 minus 9. It is minus 9. Next question of this. Find the velocity when find the acceleration when velocity equals to 10. Suppose it's written something like this. So first, sir, find the Vt equation. So 3t square, it becomes 60 minus 12. Find the acceleration time equation. It becomes 6. See, the acceleration becomes constant. If the acceleration is constant, irrespective of any velocity, acceleration will have the same value. Okay. Irrespective of any velocity, acceleration will have the same value. And next, if I say find the average velocity between t equals to 2 to t equals to 4, what's the general expression? V average is termed as the displacement between t equals to 2 to t equals to 4 divided by 2. Why 2? 4 minus 2. I write over here 4 minus 2. And how to find the displacement? Sir, x at 4 minus x at 2 by 2. Done. If people says find average acceleration, find the average acceleration between t equals to 1 to t equals to 3. It means acceleration average. Velocity at the instant 3 minus velocity at the instant 1 by 3 minus 1. So these are the various questions that are asked. Okay. Now another important question that is asked only twice. Find the distance. That I will show later on, not right now. Okay. So this is one of the beautiful sums. Next, delve into some other sum. Okay. Next is what? Sir, next do a few things about some graphs. Some graphs, and we have plenty of sums. I will do it later on. Let's do bit of graphs and I will end the lecture and we will continue with the next lecture. Okay, sir, in the bit of graphs, what we have? What we have in graphs? Sir, I am using a shortcut, so please remember the shortcuts. If you have anything, something sort of like this, any scenario something like this means slope is positive and increasing. Just remember this thing, slope is positive and increasing. Any segment you have, any segment you have, first the slope has to be positive and increasing. Next, if I have some sort of graph, it means slope is positive but decreasing towards 0. Next, over here. Now over here, this is what? Slope is negative and it is decreasing. Yes, another segment. This sort of graph. This says slope is negative and it is increasing. Why I say this thing? Because slope of xt curve gives us velocity. Slope of vt curve gives us acceleration. You should keep it in mind. And important thing, sir, this is a straight line. I know how to write the straight line. This is a straight line parallel to x-axis. This is a straight line parallel to y-axis. I don't require any sort of parabolic equation right now. No. So this is the first important scenarios, and how it is given, let me show it. Okay, so how we apply this thing? Suppose this is the curve, say xt. A, B, C, D. Okay, if it says during which segment, during O, A, B, you keep, this so you got this thing clear. B, C, D, E. During which segment acceleration is negative? Acceleration is negative. This is xt curve. This is xt curve. Now, students do get confused, sir. How to find the acceleration? If it is given initially, the body may be at rest. Body starts from 0. Chalo, let me show you the technique of doing these things in a single line. Draw VT curve. Draw VT curve. See, for your assumption, I have said let this be 0. It may or may not be 0. It is not necessary it has to be 0. It can be anything. Just for our assumption, let us check. Now see, this sort of curve. This sort of curve signifies what? Sir, this sort of curve, okay, I have written this sort of curve. No, sorry, you can't say 0. Say the body. Acha, don't need to write all these things. I have given this curve. So that means x is positive. Two things we have to check. x is positive. Yes sir, x is positive. इसका मतलब क्या हुआ? x positive का मतलब क्या हुआ? बंदा दाहिने की तरफ जा रहा है. Okay, x positive मतलब the body is moving towards right. Okay, fine. And the speed velocity is decreasing. हाँ, you see the slope is decreasing. The slope is positive and decreasing. Positive decreasing का मतलब क्या हुआ? Positive decreasing का मतलब हुआ velocity positive के तरफ था, मतलब positive है, but गिर रहे. यहां आकर देखो थोड़ा बहुत ये एकदम ऐसा होता है ना, समथिंग लाइक दिस. ओके, एक फ्लैट टाइप हो गया. फ्लैट, ये फ्लैट सिग्निफाई कर रहा है कि वेलोसिटी कोई भी पॉइंट में आके जीरो बन गया. वेलोसिटी कोई भी पॉइंट आके जीरो बन गया. ओके, अब अगेन दिस कर्व्स इज समथिंग लाइक दिस. फ्रॉम बी द कर्व्स लाइक दिस, मतलब अब यहां से वापस बंदा यहां से यहां पर गया. अच्छा चलो मैं इसको एकदम ड्रॉ करके दिखा रहा हूं. सोच लो ये हुआ तुम्हारा x इक्वल टू 0. ऑब्जेक्ट यहां से यहां पर मूव किया. ओके, रुक गया. फिर ऑब्जेक्ट ने यहां से यहां तक मूव किया. फिर ऑब्जेक्ट ने यहां से यहां तक ऑब्जेक्ट रुक गया. फिर यहां से ऑब्जेक्ट ने यहां से यहां तक मूव किया. तो इसका मतलब वापस वेलोसिटी पॉजिटिव हो गया. फिर कितना होगा सर? ये और ये सिमेट्रिकल है, ये हमको पता नहीं. It can go higher up or it can be lower also. So I don't know what is this thing, how much extent. No. Then the displacement is along a straight line. इसका मतलब तब वेलोसिटी क्या हो गया? कांस्टेंट हो गया. तब वेलोसिटी क्या हो गया? कांस्टेंट. मतलब ये बंदा सीधा ही चला गया, इधर कांस्टेंट वेलोसिटी. अब इस केस में वेलोसिटी डिक्रीज किया, इस केस में वेलोसिटी इंक्रीज किया, और यहां पर वेलोसिटी कांस्टेंट. वेलोसिटी जब इंक्रीज करता है तब इसका मतलब हो गया एक्सेलरेशन ग्रेटर देन 0. इसका मतलब एक्सेलरेशन लेस इक्वल टू 0, और इसका मतलब एक्सेलरेशन लेस देन 0. So in which segment the acceleration is negative? The acceleration is negative from directly O to B, means O to A and A to B. Okay, so this is a small application of the graph. Okay, now I will show many other applications. I am dividing the lectures into 40 minutes each, so that you people don't get stressed out. 40 to 45 minutes. Next again I will put another lecture regarding 1D motion under gravity, and I will be starting off with 2D. Okay, chalo, bye bye.